Right. Well, now it's time to start. So welcome everyone to the webinar, Optimize Your Bifacial PV Tracker Project to deliver extra energy gains. So today we'll have three experts who will let us know how you could best design and set up your project, your bifacial PV project to deliver extra gains. As a reminder, we will be recording this session and we'll send you the recording and the slides as well early next week. In the meantime, well, I'll get the experts to present themselves. So, Javier Tamayo, if you could say, in a couple of sentences, who you are.
Yeah, good afternoon, everyone. My name is Javier Tamayo. I'm from the engineering department here in STI Norland, and I'm connected indeed from the headquarters here in the north of Spain, in Pamplona.
Thank you very much, Javier. Roger, could you tell us very briefly who you are?
Yes, my name is Roger Font. I'm the Global Head of Project Finance Asset and Special Lending in Banco Sabadell, and I'm connected from Barcelona. And for those who don't know us, Banco Sabadell is one of the leading banks in renewables in Spain, and we are one of the market leaders in merchant financing in Spain. But Banco Sabadell has presence in UK, France, Mexico, US, and Latam.
Thank you very much, Roger. And then last but not least, Javier Diaz, if you could briefly introduce yourself.
Hello, everyone. My name is Javier Diaz Berrade, and I work for CENER, which is the Spanish National Renewable Energy Center, and I'm here connected from Pamplona as well, from the north of Spain.
Thank you very much, Javier. So, well, you'll be the first one to speak. So if you could start sharing your screen. And well, in the meantime, I can see that quite a lot of people have just come into the room. So we will, if it's your first time, you know that we'll do the first presentations first, and then we'll have a questions and answers session. So you can go to the Q&A box and pose your question whilst Javier and the other presenters are delivering the presentation. So, well, over to you, Javier. You're on mute, by the way, so I can't hear you.
Sorry.
Oh, right, much better now.
Thank you very much, Carlos, and thank you for giving me the opportunity to talk here in this webinar. Well, we are going to talk about bifacial PV. So bifacial PV, as a first introduction, bifacial PV installations are the future, but also the present of PV industry. They are a hot topic in this industry. If we see these a couple of graphs from the International Technological Roadmap PV issue from 2020, we can see a clear trend in the bifacial cell production and in the bifacial module production, which is clear gaining market in the PV industry. So we at CENER also have interest in doing some research and development here in this field. So we have developed our own experimental PV plant. So we have some fixed structures, some trackers, a meteorological station. We can modify the mounting of the modules. We can modify the albedo. So we are doing some research and development on this topic. So in any kind of PV installation, the target is to increase the energy generation. So we have some PV modules, we have a specific location, we have a supporting structure, and in each PV installation, what it is important is to perform a good design to increase that energy generation. So, and we have to look at different PV generator aspects. Some of them are related to the location, for example, the meteorological conditions, for example, the terrain orography, for example, the albedo, for example, the soiling that may happen more or less depending on the situation of the PV plant. Some of the aspects are related to PV modules. For example, the bifacial factor in case of bifacial modules, obviously. The temperature coefficient of those modules, the mismatch that can happen between the cells inside the modules and between the modules inside the PV string. Some of the aspects are related to the supporting structure. For example, the PV module's elevation above the floor. The back shadowing that can be caused by the supporting structure, or the pitch between the structures. And we can consider also other conditions, like other specific requirements, because there are many kind of PV installations. So in some of them that can happen some specific requirements. And we have to combine everything all together to do a very good PV generator design. In this presentation, I'm going to talk only about to increase the energy generator. I'm not going to comment anything about economic part of the design. So we can start from a PV module, from the PV model characteristics. Next, we have to decide a type of supporting structure that can be, for example, fixed tilt frame or a tracking system. Then we have to take care about the supporting structure mechanical design. In the case of bifacial modules, it's important to try to avoid or to try to minimize the shadows in the rear part. Then we have to think about the operating conditions of the supporting structures. Sometimes, for example, it is needed to modify the tracking algorithm of the tracker in order to increase the energy generated at some times of the day. It may happen depending on the conditions. And it's important as well to take care of the electrical connections. Usually in bifacial installation, the current levels are higher, so the series resistance can be higher as well. And finally, there are some softwares that already have some tools regarding bifacial modules, the bifacial part of the installation, like PVSys or SAM from NREL, which can help us to estimate the LCOE final of the installation. So if we take a look at the bifacial PV module installations, PV module specifications, well, we can see here the design, the mechanical properties. We can see here a couple of examples from two well-known manufacturers. We can see the electrical characteristic at standard test condition and OCT, but how can I know which is the maximum power gain of each module in our installation? Well, we have this parameter, which is called the bifaciality, that in these two cases are 70 plus minus 5%. But how do I know how much power will I get in my bifacial PV installations? Well, in these two cases, for example, we don't have much information. We have another part of the specification which says that in case you have a maximum power gain of, for example, 10%, this will be the electrical characteristics that you will have, this power, this open circuit voltage. But how we do know which is the power that I will get? So I work in the PV module testing laboratory in CERNER. I'm going to comment a little bit about how we measure the bifacial modules. We have a standard defining the procedure to measure bifacial module. First of all, we do a front side characterization. We measure the IV curve of the modules, applying a irradiance in the front side of 1000 watt per square meter without any irradiance incident in the rear part. Afterwards, we do a rear side characterization. We apply 1000 watt per square meter to the rear side. We calculate the bifaciality coefficients, which is defined as the ratio between, for example, here in the short circuit current, as the short circuit current in the from the rear side characterization divided by the short circuit current in the front side characterization. And afterwards, we apply irradiance at higher levels we measure the IV curves at higher level of irradiances. For example, we can measure simulating 100 watt per square meter or 200 watt per square meter, and we have here some points in that we can fit to a straight line, and from the slope of this line is called the BIFI, which is the rear irradiance driven power gain yield. So I mean, this slope is how much power I will gain in the installation for every watt per square meter that is incident in the rear side of the module. Some manufacturers are already giving the electrical parameters at a conditions called BSTC. As far as I know, they are not defining in any standard, which is 1000, which is the irradiance is the value that changes, which means it's a frontal irradiance of 1000 watt per square meter and a rear irradiance of 135 watt per square meter. The temperature, module temperature, and the spectral distribution will be the same. So which are the factors that affect the energy generation? From the point of view of the module, there are three different parts. The irradiance, we know that we have a frontal irradiance and a rear irradiance. The spectral distribution, the frontal irradiance will have a spectral distribution which will be more or less similar to exactly equal to the one of the front of the monofacial installations, and we will have a rear irradiance. In this case, the spectral distribution of the rear irradiance will be dependent on the soil, like this. Probably this is kind of a second order of magnitude influence in the output power. So I'm going to not talk much about this. And finally, the module temperature that may be affected in the installation conditions. Regarding the irradiance, we have the frontal irradiance that may be exactly as a monofacial installation. Just to remark that the energy gain due to the use of the tracker depends on the latitude of the installation. Regarding the rear irradiance, we have the albedo, which depends on the soil. There are soils more or less reflectant, and it's variable along the time of the day, along the day in the year. The module elevation, the higher the elevation above the floor, the bifacial gain is increased. The pitch, the longest the difference, the longest bifacial gain. The non-uniformities, they are caused by shadows. In the modules installed in the higher rear, in the edges of the tracker, they have higher rear irradiance that have to be taken into account, and sometimes they may happen rear soiling. That also it's an important issue. Regarding module temperature, we have here an equation that can model the module temperature. Depends on the ambient temperature, on the irradiance, on the wind speed, And we, in this standard, these two parameters, U sub 0 and U sub 1, are determined. They depend on the module type and the mounting system. So looking at this equation, at the higher irradiance, the higher the module temperature, although not necessarily higher in monofacial installations, because U sub 0 and U sub 1 might be different. Irradiance non-uniformities can lead to localized heating, depends on the non-uniformity. Higher elevation above the floor usually means higher wind speed, at least in open field. So that will mean a lower temperature, but it may depend on the orography of the terrain and then different parameters. And the module temperature is related to the maximum power through the maximum power temperature coefficient, which in these modules is about minus 0.35, minus 0.40% per degree. So as the conclusions, there is a clear growing trend for bifacial PV installation. The complexity is much higher than in monofacial installations. We have commented some parameters for the bifacial module characterization, like the bifaciality or the BIFI. And we have commented some of the many factors to be considered in the project design, like the albedo, like the module elevation, pitch, non-uniformities. So thank you very much.
Thank you very much, Javier, for your presentation. Next, we'll have next Javier, which is Javier Tamayo, will be delivering a presentation. In the meantime, I'd like to remind you that you can ask questions. I can see that you're being you there in the audience are being quite shy, but no, go and ask questions. This is your chance. We'll go through some of them at the end of the presentation. So, Javier, if you have your slides, if you'd like to start sharing your screen, or your microphone is on. Okay, perfect. Well, over to you.
Okay, so good afternoon, everyone. In my part, I will get into detail about bifaciality and how STI has upgraded its tracker, its solar tracker, to this new trend of photovoltaic modules. Well, here we see a list. In the past 2 years or so, we have developed a lot of projects with this new module. And if we gather them all, we sum up more than a gigawatt of power peak production. So the question is, how bifaciality works in solar trackers? Well, what we see is that there are 3 main parameters that are very important, which are the irradiance, the albedo, and the view factor. The point is that the first 2 are already defined for each specific project. So maybe we could invest to improve it, the albedo case. But we guess that the common way is to assume a natural value, a value that might change throughout the year, and to presume that that value is going to be maintained throughout all the lifetime of the photovoltaic plant. So the point is that we see the view factor as the key point in where a solar tracker, we can assess the suitability or not to produce that profit, that bifacial gain that this new type of module is offering. So how do we define that view factor? Well, we need to study how the irradiance is reflecting in the ground and capturing by my collector. So step 1, we know that reflection is a diffuse phenomena, so it's followed by the Lambert's-Cosin law, and depending on where do I locate my collector, my collecting surface, respect to the ground, to the reflecting surface, it will have more efficiency or less. So as we see in those blue line graphs, these are the theoretical view factor of our specific tracker in 2 different degrees of rotation, in 0 degrees and 45 degrees. Step 2, we have to adjust that view factor in terms of how my collecting surface is facing the reflecting surface, the ground. So depending on how much perpendicular to the ground does my surface look at the ground, it will have more or less efficiency in order to capture that reflecting irradiance. And step 3, which might be the most important one, we have to put that view factor into scale to proportionally increase the view factor. Depends on if I am considering the shaded part of the ground, or I am considering the sunlight area of the ground. So at the end, we get a graph like the one we see in orange color, which is very similar to those that the software such as Bifacial shows in the bifacial procedure. Okay, so that's basically what we have done in this analysis. We have defined both a collecting surface and also the ground surface. We have divided both into 12 equal parts. And by geometrically calculus, we have defined how much percent of irradiance each of my cells, each of my photovoltaic cells is capturing. At the end, we sum up the rays impacting in each of my cells, and I can plot the total percentage of irradiance that each cell is capturing. By the difference of that percentage, I can also define another parameter that we will see later, which is the mismatch, as Javier has mentioned before. And finally, in blue line, we can consider also the shape of the torque tube, which affects to the intermediate cells, because the torque tube is in the middle of my tracker. And we will see also some of the values we have defined later. Okay, so in order to assess different types of tracker, we have considered another parameter, which is the normalized height. That is the ratio between my collector height and my collector width. So as we see here on the table, no matter what is the size of my tracker, the values of the view factor keeps the same. What's the point? The point is that in the real market, the 2 most common trackers are located in different ranges. So as we try to highlight here, the 1P configuration stands in a 0.75 of normalized height and with a view factor of 0.1450, so 145. And the 2P configuration stays in a 0.6 value of normalized height with a view factor of 0.137. Here we try to highlight the same idea. In the left-hand side of the screen, we see 3 different trackers, even an idealistic one, which is the 3-portrait configuration. And as we see, our table, our collecting surface gets wider, but so does my pitch. My pitch is larger, so at the end, geometrically speaking, we capture the same percentage of irradiance. What's the real case scenario? Well, on the right-hand side of the screen, we see both 1P and 2P configuration trackers, where we can see that triangle, that amplitude in dark orange, is lost by my 2P collector because of that location in a lower range. As we spoke before, directly related to the reduction in percentage of irradiance capture, we can analyze the mismatch. And we see that this parameter decreases with the normalized height, because it's logical that the farther my collecting surface is from my emitting surface, which is the ground, the more uniform the capture irradiance will be throughout those 12 cells in this case. We have also calculated the shading factor. With most of them is, or the part is the torque tube is the element that makes the higher shade. And as we see here, it increases with the normalized height. Well, this might not be that intuitive, but we must take into consideration that the higher my tracker is, the higher the bifacial gain will be. So at the end, the affection of shading factor might be taken into account, assuming that value of bifacial gain. Here as well, as we know, reflection is a diffuse phenomena. So no matter in this specific rotation 0 degrees, right, which is the most bifacial gain we have, no matter if we have an intermediate gap in between the modules in the 2P configuration, at the end, the shade produced by my torque tube will eventually impact on the rear side of my module. Okay, and at the end of the process, what we have eventually defined has been the bifacial gain. We have considered the B factor, also the shading factor, also the mismatch, and then we can plot the bifacial gain that logically it increases with my normalized height. And as we see in the common tracker we have in the market, it's around 7%, 8% for those common values of albedo, which are around 0.25. Here we saw a graph summarizing all these 4 elements. And as we see, the higher the normalized height is, the more bifaciality gain we will achieve. So the question now is, if bifaciality rewards greater value of that parameter, where do we reach the optimum point? Because as we see here, the B factor improves, and also we have like 4% more of capture irradiance by growing my tracker, for example, from a normalized height of 0.75 to a normalized height of 1.50. Well, as we know, for solar investments, it's very important to take a lot of concepts into account, not only energy return, but also installation, maintenance, and so on. And at the end, what STI offers to the bifaciality market is a dual road tracker in a 1P configuration with a module height around 1.5 meters and a total length around 75 meters, because 65, sorry, meters, because of that last higher dimensions in current models, right? So this has been my presentation so far. I hope you find it interesting.
Thank you very much, Javier, for your presentation. I can see that there are quite a lot of questions coming in, so keep on sending the questions if you have any. And then, Javier, if you could please stop sharing your screen so Roger can deliver his presentation. There we go. Roger, over to you. Whilst you get ready, I'd like to remind everyone in the audience that we are going to send you the video recording and the slides as well. So
okay, perfect. I'm going to share a presentation, but I'm going to be fairly quick because to leave time to the questions.
Okay.
1 second. Well, some of you may know Banco Sabadell has been in financing renewables since 1992, and we participate in both obviously in financing, regular debt, but also we have a debt capital markets. We have a specific fund for for renewables, and also in the fund for industrial. Just worth mentioning that our fund bought 41% of STI Norland, so we cover all aspects in the renewable sector. As I mentioned earlier, we have a presence in Spain, UK, France, US, Mexico, and LATAM, and in all of them, we have been very active in financing renewables, especially in Spain, in which we participated with the 15 gigawatts. In the UK, we are also very active in Mexico. These numbers need to be updated because this is a couple of years older. So we are, I would say, a player in all these geographies, and we know most of the relevant sponsors. And just so that you know, the ones that are come from Spain, obviously, we have been very successful in merchant financing. Last year, only in Spain, we signed 32 deals. And the most relevant of those is that 13 of them were merchant, which 5 of them were with PPA and 8 of them were without PPA. And if we take a look at the 2.3 gigawatts that we financed last year, 60% were PV, and we had some of the bifacials in those, and 40% wind farms. So we are one of the most specialized banks in financing renewables, and these are some of the deals that we participated in one of the largest transactions in Spain, and in the last couple of weeks we also have signed very important deals in Spain. And just so that we have time for the questions, and then we can talk about it and how we treat the PV plants that have bifacials, because for the banks and from a conservative point of view, it raises some questions. And I think that this trend of implementing bifacials in the PV projects, it's 2 or 3 years down the road that we will see the upside in financing. Directly, it's kind of difficult to assess because there are a lot of factors, and the banks usually are fairly conservative. So when we structure the deal, we may not take the full advantage of the bifacial, but once, and it's an upside for the sponsor. But I think that when we have these plans up and running in 3 or 4 years down the road, in which we can assess the benefits, then it's when we can have a new business model based on the track record and see that upside. The rest of the presentation, just one in all the geographies. In number one in Spain in terms of number of deals, not in amount. As well, these are all we provide feed-in tariff, auction Spain, and merchant. But what I think it's relevant for this webinar is what I just said. Okay, so I'm gonna pull down my presentation so that there's more time for questions.
Thank you very much, Roger. And well, I think, first we'll go through some of the technical questions that they have been asked here, and then it'd be also interesting to look at some of the financial implications of these new technologies. So I can see by the type of audience we have here that they are very interested in how to measure the impact of albedo and the configuration of a plant. So let's go with the first question. So it's by Raid Bakairat, and he's asking whether we are making any progress in having common standards that all can follow in measuring or calculating the energy yield of bifacial modules on different sites. Who wants to go first?
Well, I will try to answer, but I can't really, because well, I'm related more with the module part. I work with the module standards of IC. I'm not related as close to the installations part, but I guess that for the PR calculation, you should take into account as well the rear irradiance. I'm not sure exactly how long are we in the standardization.
Right. Would anyone else like to add to that? Are there any like tracking standards, for example, you're aware of, or even ironed? Well, they're ironed, really.
Well, from STI, well, we have get into details into the theoretical equations and how that all these a lot of parameters that are involved in bifaciality. How do we measure them, model them? But I'm not very familiar with the standards because as it's a recent market, I'm not aware of what's the page of that book, actually.
Okay, thank you. Then the next question is was asked by Michelle, and she asks, may I ask you if you have experienced an increase in the irradiance non-uniformity on the rear side caused by shading from the module frame or the structure that supports the module?
Yeah. Well, actually, we are experiencing with a partnership with a university in Madrid in order to assess how close the torque tube is to the modules and how does it affect to the shading factor by upgrading that parameter. What we have seen is that that common height of 60, even 90 millimeters of height between the module and that element is enough to spread that shade. And as the tracker height is in another magnitude, we don't see larger changes when changing that distance from my shadowing element, right?
Okay.
Well, regarding the module frame, well, if the module has a frame, it can cause a non-uniformity in the rear side, yes. So that's why many modules are glass and they don't have any frame.
And what are the implications for some of the in the audience, I'm sure wouldn't know, of non-uniformity?
The implications of the non-uniformity in the rear surface may lead that well, usually the modules are series connected. Well, in the new designs, they have two parallel circuits. But if some of the, as they have a lot of series connected cells, the current circulating for all of them has to be the same. So if the current, in some of them are reduced, or we have two options, or the current is the lowest of all of them, or you can have a slight problem of hotspot there. Yes.
Right. Okay. So it could be a reliability issue if it carries on.
Yes, if we took it to the limit, it could happen, but it's doubtful that a manufacturer can give you a module that can have a hotspot due to the rear non-uniformity. That will be too much, I think.
I see. Okay. And well, I can see a couple of questions regarding the height, you know, where you put the panel, you know, and also about the distance between the torque tube and the panels. And you mentioned, Javier Tamayo, that you are carrying out a study with one of the universities in Madrid. Is that study going to be available, or is it available to the public, or is it a private piece of research?
Well, these results have been developed just internal by the time, but as we see, analytica speaking, we see that affection in the intermediate photovoltaic cell, right? In those cells that are closer to the torque tube, having a greater or lower the profile height does not spread that shadow in a large dimension in the rear side of the module. So, well, we feel confident about the height we have in the product nowadays, and we foresee that we're going to stay in that range of dimensions so far.
Okay. And going to the next question, which is by D Rash, he's asking whether there are any considerations for projects near the equator and further away from the equator regarding the optimum angle. You know, what are the how do you optimize depending on where you are located?
Yeah, well, geometrically speaking, it's a great difference between those locations near the equator and those far away from the equator. In the analysis we have done, we take the horizontal irradiance as a reference, and at the end, that tool can give us not only the direct irradiance but also the diffuse portion of the irradiance. So at the end, we are we are putting on a scale the bifaciality in terms of irradiance. So the latitude is included itself in that data sheet or in that database that we use in order to define the bifacial gain.
Right. Okay. Well, I think, you know, now we have covered some of the technical questions. I'd like to get answers to some of the financial questions. So one of them is also by D Rash, and he asks on the, his question is, any views on how much gain from bifacial is considered by banks in financing case?
As of right now, I mean, first of all, once we look at a transaction, we take a look at the whole transaction. So we have to see if it has PPA, if it doesn't have PPA, if it's pure merchant, if it's auction. So we put that into the whole analysis of the transaction. The truth is that as of right now, it's so new, the technology, that we can put a few gains into the model. But it's something that the model looks at more from the sponsor side when they look at their internal IRR than the banks itself. Then there's another question regarding the debt service cover ratio, and that totally depends on the type of the transaction. If it's a transaction with a PPA in which the off-taker is investment grade, it will be 1.3. If it's a pure merchant in Spain, 1.5, but the 1.5, you need to look at it based on the electricity price curve that you are using. So the 1.5 by itself, it will not tell you a lot, or you need additional information. Then I think that it's more, as I said, like the sponsor to look into the internal IRR than not the banks. The banks can do a little bit, and we can accept to take into consideration some of the gains if all the other factors are not really tight and are under our rate framework, for example. But as I said, I think that it's going to be 3 to 4 years down the road once we have a track record in which then we can say, okay, the gains are 5, 6, 7, 8%. Then we look at the history, and now taking into consideration those gains for the remaining life, how much debt I can put into the project that I make. So it's going to take a little bit long because obviously the banks are probably the most conservative of all the parts, and it will take a while.
Right. Thank you, Roger. So in essence, you know, you need more projects on the ground operating for longer, and then you'll be able to tell what difference there is between bifacial modules and monofacial and plants that use monofacial modules?
Yes, last year we financed around 15 or 16 PV plants only in Spain. Then we financed some other in the US, Mexico, US and Mexico. But out of these 15 and 16, I think there were only two that they had bifacial. So it's a small number. And in terms of megawatts, it was less than 5%, maybe. But now, since this trend is growing on, we are going to start to see more. And then once we analyze another project, then we can look at the history. But the plants that we finance, they are still in production, or they haven't had one full year of production. So we don't have that much data.
Okay, thank you. Thank you very much. So, well, there are still some quite a lot of questions here, and one of them is by Alejandro Pagano, and he asks, are there any changes in the way PR is calculated when using bifacial modules as per IEC 61724-1?
Well, I think this is this the same question that we have answered before, maybe? Well, I'm not really sure how the PRs have to be calculated, because, well, in the end, it's a comparison between some modules, how they should perform. So there are several equations. You can correct the temperature, you can correct. So, well, I guess you should use also the rear irradiance, but there are several rear irradiance differences. You can measure it at several points. So I'm not sure exactly. I'm not an expert in that point. But I guess you should use the rear irradiance as well.
Right. Okay. And more of a general question. So, you know, here we're talking about optimizing bifacial PV projects. So, what are the top 3 things that someone who is building who's thinking of building a project with PV bifacial PV modules? What are your top 3 recommendations or things to look out for? Javier Tamayo, maybe you look like you might want to start.
Yeah, well, I'm not getting into economical details because what we have seen is that even a very little increase in bifacial gain does represent a lot throughout 25 years of warranty in the project. But if we look into just the technical point of view of bifaciality, there are 3 main aspects that are really present in bifaciality, which are, of course, the irradiance, as we got one question about the equator. Well, depending on what location in the world we are, the amount of irradiance will be different. The albedo, but as I said in my presentation, we don't see the albedo as one parameter that in terms of area of a lot of meters square, we are going to invest on that. And the third point will be the view factor that in that case depends totally on the geometry, on the solar trackers, and how does my module face the reflecting surface that is the ground.
Okay, thank you, Javier. Javier Diaz, would you like to add anything to that?
Well, I think I agree with my colleague. I will, for any kind of project, I will recommend to reassure the quality of the products. I think it's very important because we are designing installations for long in 25, 30 years. So you have to be sure that the components that you are using are reliable. That's my point.
And Roger, from the point of view of the financier, any recommendations to anyone wanting to carry out a project with bifacial PV modules?
No, I think that the PV plants will have to improve, and this is one way to improve their productivity, and this is very important because at least we are talking to the manufacturers, and we don't see that the prices of the PV modules are going to go down as they have done it in the past, and the way to improve it's this way. Then it may take a little bit to the banks to move on and accept those gains, but in the medium term, not in the long term, but in the medium term, once we have a track record, it can be very beneficial. Especially we are specialized in financing full tenor, but we all know that we after some years we usually refinance it and take the historic data in order to build the next case.
And you know, as of now, where are bifacial projects being developed like throughout the world? I see a question about, you know, about bifacial projects being developed in the Maghreb, Morocco, but are they quite evenly spread, or are they concentrated in a specific market? Not all at the same time.
I actually don't know. I would have to check with my colleagues in Mexico and the US. Since we have been very active in Spain, I'm not familiar. I would have to check with my colleagues in US and Mexico.
Mm.
I'm afraid that I can't answer that question. I don't know really.
Yeah,
Okay.
from the projects we have developed, they are located more or less in the same areas that the monofacial module will have an advantage, right? Like South America, latitude that has a lot of irradiance, not a very high portion of diffuse irradiance. But what is interesting about bifacial at the same time is that maybe in places that might not be that clear to monofacial, in terms of albedo, well, it's theoretical information that we saw, but depends of the albedo being on a snow place, for example, or even more specific cases, it may cause an improvement that was not possible in monofacial as well.
All right, good. Well, I think, you know, we still have some questions left, but we are actually coming towards the end. There is one last question which is quite interesting, which is about the use of bifacial PV modules in the floating PV plants. Has that been done? Do you know anything about this? Are there any experiences?
No, from STI we have not dealt with that so far.
Okay, maybe it's a new. I'm sure there are studies on, you know, different kinds of surfaces and whether the surface of water would be different and have a different impact, but maybe that's something that needs to be further studied.
Yes, I think so. Water can be a very high reflectance surface. So depending on how the system is designed, it can be a very good idea. No, I don't think there's a lot of experience yet, but I think it's a good point.
Right, good. Well, I think like all good things, this webinar also must come to an end. So I'd like to thank both Javier and Roger for being here, and to everyone in the audience for bearing with us. And asking questions and getting involved. So don't know if you have any parting words for the audience.
Just to say thank you to you, Carlos, and to the audience as well, and let's see what does bifaciality has for us in the future, because it's not the future as Javier said, it's the present as well.
From my part, I think that first of all, thank you for everyone, and I think it's a growing trend, and the banks will have to get used to and have a better analysis of the technology.
Well, for my point, yes, thank you, Carlos. Thank you, the organizers. Thank you, the audience. I think PV, the whole PV has a bright future, and Bifacial is a big part of that cake. And so it has also a very bright future. Thank you all.
Thank you very much. Well, if you like these kinds of webinars, you know where to find more. Go to atainsights.com, and we have a lot of webinars planned for you. And once again, thank you to everyone, to all panelists today, and to the audience, and see you next time.